this is John from caveofprogramming.com. In this tutorial we're going to take a look at setting the colours of pixels in our program. So in the last program that we created, in the last tutorial, we turned the entire screen white just by doing a mem set on the buffer where we store the pixel information. So here I've set all the bytes in our pixel buffer to the maximum possible value of FF in hexadecimal, which is 255 in a decimal system. So now let's go ahead and see if we can change the colours of individual pixels. So the first thing I'm going to do is do a mem set to 0, and then we should get back to black. So we can just clear the buffer and set every byte in it to 0 so we get black. Now let's try setting an individual pixel. This is going to be quite hard to see. So after this I'm going to go on and in this tutorial we're going to set the entire screen to a particular colour, but we'll start with just an individual pixel. So we've got the buffer here containing our pixel data, and we can pick any particular index in this buffer up to a maximum value of 1 less than the screen width times the screen height. 1 less because it's an array, and of course arrays start numbering at 0 up to the number of actual values that we can store in them. Let's just put something in here like 600. So we've clearly got more than 600 pixels, so I'm not sure where this is going to appear on the screen. Actually, come to think of it, it's going to be near the end of the top row, so maybe I'll pick a bigger value here. Let's try I don't know, let's try something like 30,000, and let's set that equal to a value. Let's try white to start with. So each pixel occupies 1 byte, and that byte, you'll recall, allows us to set the red, green, blue and alpha values, and each value has a value from 0 up to 255 maximum in decimal, or FF in hexadecimal. So what we do is we pack all those 4 values, those 4 bytes, into a single 32-bit integer type. Now if we were to try to write this out in decimal, it will not be easy to understand what's going on, but if we write it in hexadecimal, as you'll see, it's a lot easier. So I'm going to write a hexadecimal number here, and the first, so this has got to be 0x. So the first byte, we think of it as being on the left, although whether it really is or not in a computer's memory, well, the computer's memory could be upside down or anything physically, but the first byte here, we're going to give a value of FF. So FF is the maximum value we can store in a single byte in hexadecimal, and the next byte after that is also going to get a value of FF, and so on for the remaining bytes. So this value here, 0x followed by 8 Fs, that's setting all 4 bytes to the maximum FF, and we're going to be looking at this a bit further in a future tutorial, exactly how this works. But for now, just think of each of these, every pair of Fs is a value that we're setting either for the alpha value, or the red, or the green, or the blue. Let's have a look at this. Let's run this and see what it looks like. So if I run it, I don't know if you can see that in screen capture, but there's a white pixel just above my mouse here. Let's quit that. So if we look at the pixel format that we set when we created the texture that we're writing this data to, we think that the first pair of Fs should be the red byte, then the green byte, the blue byte, and the alpha byte, which we're not going to use. But in practice, it doesn't seem to quite work like that. I don't know why not. So you need to do an experiment here on your system and figure out which is the alpha, which is the red, which is the green, and which is the blue. We're going to do that in a minute, but let's first set the whole screen to a colour, because it's going to be easier to see than one individual pixel. So I'm going to use a for loop here. I'm going to say for int I equals 0, while I is less than, and I want to visit every pixel on the screen. So it's going to be I less than screen width times screen height, and I plus plus. And we're going to set each pixel, initially let's set it to white. So I'm going to say buffer I equals OX and 1, 2, 3, 4, 5, 6, 7, 8 Fs, just like this. So this is going to do the same thing as a mem set. Originally we're doing mem set to black, but before we had mem set to white. It's just going to do it more slowly because we're using a for loop, which is going to be slower than a mem set. But the advantage is that, well, actually, there's not a lot of advantage here, except that we can only mem set all the bytes to the same value. But if we do this, we can now pick out, we can now change individual bytes. We can deal with each of the bytes in the groups of 4 bytes, where 4 bytes represents 1 pixel, separately by changing the Fs in this 32-bit 4-byte number. So let's just run that and check that we get a white screen. So now it's white. And let's try setting the middle pair of bytes to zeros. So a pair of zeros here and here, and the end bytes are going to be F. So I'm not sure which one's red at this point and which one's alpha, but we should see red here. And I'm not even sure whether FF means completely transparent for the alpha or 0 means completely transparent. We could check that, but I found this doesn't work with this program anyway. The alpha doesn't seem to do anything, so it doesn't seem to matter. Let's just run this. Now we've got a red screen. So if I make the first byte 0 and the next byte FF, let's take a look at what that is. So that's now green. And what about the next byte here? Let's run this. And this is now blue. So it seems as though what we've got is red, green, blue, and the last Fs are the alpha value here, which is what we'd expect from this actually. So I'm not sure why I thought it wasn't in fact in this order, because this in fact seems to work perfectly. And we could get combinations of colours as well. So if we've got blue and green, I think that should be yellow, shouldn't it? So let's try that. If we run this, I guess blue and green isn't yellow. Okay, we've got some sort of bluish colour there. Oh, I've set too many Fs, that's why. So we've got 2 zeros, we need 2 Fs. So that's the red, the 0. Then we've got green is FF, blue is FF, and alpha is FF. Yeah, so I guess I was right the first time. I don't know. Let's try red and blue, see what that does. So now we've got a sort of purple colour, which is what we'd expect. How we'd get yellow, I've forgotten. We'd have to look that up, or I'd have to. But I guess yellow would be some combination of blue and green. Let's just experiment here, because this is quite interesting. Let's try, we'll leave red at 0, 0. Then for green, let's try FF. And for blue, let's try 8, 0, because 8, 0 is equivalent to, I guess, 128. It's half of 256, roughly half of FF. Let's try that. And now we've got a sort of greenish colour. I'll try one last thing. Let's try maximum green, and let's try half of green. Did I just have that? And maximum blue. Anyway, this is getting silly. So I'll leave you to experiment around with this, and I'm going to go away and look at what yellow is in terms of the primary colours here. But make sure you can get that to work on your system, and make sure you can set different colours and check which of these bytes. Remember, any particular byte is represented by 2 digits in this hexadecimal number here, and you need 8 digits total. Make sure that you can get the red, green and blue values set. Hopefully this will work the same on your system as it does on mine. You could try setting alpha here, whichever one alpha is, whether it's this one or this one on your system. It should be the same as mine, but I'm not completely certain of that. Try setting it to 0 or FF and see if that makes a difference, and keep doing that until you've figured out reliably how to get red, green and blue in here, because you're going to need that for the rest of this tutorial. So that's it for this time, and until next time, happy coding.